Some of you may not know that data centers utilize an estimated 200 terawatt hours every year. How large is this number exactly? Well, that is more than the yearly energy usage of some countries. Data centers aren't very environmentally friendly and contribute around 0.3% of overall carbon emissions. On the other hand, the information and communications technology ecosystem as a whole is responsible for more than 2% of global emissions. What's worse, ICT power consumption is anticipated to increase to 20% of global electricity demand, which would mean a significantly increased carbon footprint. We wouldn't want that, would we? Fortunately, some organizations take our environment into account, and one of them is good old Microsoft. In this video, we will be going over Microsoft's recent project, an underwater data center. But before we get into it, make sure you hit that like button and subscribe to our channel for more tech videos like this. I present to you Microsoft's efficient underwater data centers. Underwater, as in below the sea where it's dark and wet. You heard it right. But when did Microsoft make it happen? It was in the spring of 2018 when Microsoft's Project Natick team stationed the Northern Isles data center 117 feet deep to the bottom of the Big Blue Ocean. These underwater data centers contain 12 racks, 27.5 petabytes of storage, and 864 servers with FPGA acceleration. Microsoft has retrieved its container-sized data center from the bottom of the North Sea, just after 2 years of being submerged under more than 100 feet of water. And apparently, they realized that servers in its submerged data center were 8 times more reliable than those located ashore. But why did they even think of submerging these data centers? Their objective was to test and screen the performance, reliability, and fallover of the Northern Isles, the purpose-built underwater data center. But how was the idea born? It was in 2014 during Think Week, an event that gathers Microsoft employees to mingle and share out-of-the-box ideas, when the concept of an underwater data center was thrown onto the scene. The ridiculous yet brilliant idea was considered a potential way to provide ultra-quick cloud services to coastal populations, all while saving energy. The citizens from these coastal communities can happily say goodbye to faraway places with better signal. Since more than half the globe's population lives within 120 miles of the coast, putting data centers underwater close to coastal cities was a great workaround for issues related to relocation. The closer they are to these cities, the shorter the distance it would take for the data to travel. This results in quick and smooth web surfing, online shopping, downloading, online gaming, and media streaming. Imagine watching 5 of our videos at the same time. Anyway, energy-efficient data center designs were made possible due to the consistently cool subsurface seas, and having the optimal temperature needed. They can use heat exchange plumbing like those found on submarines. But to make it happen, they had to determine whether it was feasible or not. It was proven through a 105-day deployment in the Pacific Ocean in 2015, where the team demonstrated the possibility of the idea. The second phase of the project included contracting with marine experts in shipbuilding, logistics, and renewable energy to show that the idea is also as practical as it is brilliant. The underwater data center was then built with cooling systems and renewable electricity from solar and onshore wind, as well as offshore tides and waves, utilizing every possible energy source without having to compromise for environmental concerns. Pretty awesome, right? How well did Microsoft pull it off? The Naval Group and its auxiliary Naval Energies, experts in naval defense and marine renewable energy, manufactured the Northern Isles underwater data center. An Orkney, Ireland-based firm named Green Marine gave Naval Group and Microsoft support on the deployment, monitoring, maintenance, and recovery of the data center, which Microsoft's Special Projects Group operated for 2 years. European Marine Energy Centre was where the Northern Isles were stationed. The area was a test site for wave energy converters and tidal turbines. Tidal currents there can travel up to 9 miles per hour at peak intensity, and the ocean surface rolls with waves that can reach up to 60 feet or more in turbulent or stormy conditions. The deployment and recovery of the Northern Isles data center was a technique requiring an entire day on each end. It required atypically calm seas and a well-choreographed dance of robots and winches that played out between a gantry barge's pontoons. It's impressive how it only takes an entire day. You'd expect that operations like these would take around weeks or days. Enough about that. Let's move on to what the data centers looked like before and after their submergence. The Northern Isles had a glimmering white coat when deployed, but 2 years underwater was enough to allow a dainty layer of algae and barnacles to form, and for sea anemones to grow as large as the size of melons in the sheltered nooks of its ballast-filled base. Chief Member of Technical Staff for Microsoft's Special Projects Research Group, Spencer Fowers, said they were pretty impressed at how clean it was despite being submerged for that long. They did not have a great deal of solidified marine growth on it, but it was mostly covered in sea scum. Like most of us, no one wants nasty sea grime, so the Green Marine team power washed the watertight steel tube that encased the Northern Isles cooling system infrastructure and 864 servers once it was pulled up from the seafloor. After that, they transported it off to the Orkney Islands for testing. The researchers conducted these tests by embedding test tubes through a valve at the top of the vessel to gather air samples for analysis at the Microsoft headquarters based in Redmond, Washington. It was stated by Fowers that it was filled up with dried nitrogen, and it was left to wonder as to how gases that are typically released from cables and equipment may have changed the operating environment for the computers. After cleaning and air sampling, the data center was loaded onto a truck. It was then driven to Global Energy Group's Nigg Energy Park facility, located in Scotland. While the end cap was being unbolted and the server racks were being slid out, Fowers and his associates performed health checks and gathered components to ship off to Redmond for analysis. A handful of failed servers and related cables were among the components manufactured and shipped to Redmond, Washington. But how could this be? And what was the reason behind the failure? The team conjectures that the atmosphere of nitrogen, which is less corrosive than oxygen, and the absence of people to bump and knock its parts, are the main reasons for the difference. If the analysis proves that this is right, the team might have the option to translate findings to the land data centers. Now, let's move on to the real question. Was the project a complete success? Well, in short, yes. The outcome was a success. The servers in the underwater data center demonstrated a failure rate of 1/8 that of the land-based data centers. Only 1/8. In fact, the proven quality and reliability of the Northern Isles has prompted Microsoft to investigate more on utilizing underwater data centers to power the full setup of Microsoft Azure cloud services. This may have been the ultimate stepping stone that will shape the future of data centers. It was proposed through initial analysis that the successful failure rate of the underwater data center was because of the static, dry nitrogen climate compared to the land-based centers with oxygen. Other factors involved were temperature fluctuations, humidity, as well as knocks and bumps from human interactions. The Redmond, Washington-based software giant is one of the biggest data center spenders in the globe, building and utilizing hyperscale data centers all over the world. According to data from Synergy Research Group, spending on public cloud data center infrastructure hopped to 25% year over year until it reached nearly $17 billion in the second quarter of 2020, and is currently led by Amazon Web Services, Google, and Microsoft. To become carbon negative by 2030 is what Microsoft aims for, and they plan on doing that through advancing the efficiency, productivity, and sustainability of its cloud foundation. Not only that, but the company has committed itself to utilize 100% renewable energy in the entirety of its data centers by the year 2025. Way to go, Microsoft! Are you excited about these super efficient and eco-friendly data centers? Let me know your thoughts in the comments section below. Apart from that, thanks for tuning in, and if you enjoyed the video, make sure you subscribe to our channel and turn on the bell icon to stay updated whenever we release a new one.